Hey guys, we're at the Zoological Society of London at the London Zoo today, and we're going to be taking a look at where the rubber meets the road with technology and animal conservation. We're really grateful to our partners over at PeakIO and Solidigm for having us out here and their coordination with the ZSL in order to make all of this happen. We're going to be taking a look at how they're using high-speed storage solutions from PeakIO driven by Solidigm's 61.44 terabyte drives in a 1.2 petabyte array in order to provide faster and quicker insights into animal conservation, migration patterns, and everything in between from there. So we're going to go talk to a world-renowned professor of zoological conservation and how modern data center technology deployed at the edge is helping them make faster decisions in their zoological conservation efforts. Hey guys, so we're sitting down here with Chris Carbone, Professor Chris Carbone, right?
Yeah.
And we are in the offices of the London Zoo, and we're taking a look at how technology these days is helping out with conservation efforts around a few particular species. So what are you most focused on these days?
These days, we have been working with a project called London Hog Watch, which focuses on urban conservation, focused in particular on a very charismatic species, the hedgehog.
Okay,
Hedgehogs
like Sonic?
Yeah, like Sonic, but and they're a European species. They don't live in North America, so less known. So we're looking at using population estimates to improve our conservation efforts around the capital.
So what sort of challenges does the populations have around London? And
they have challenges that face many species across the globe, that you get small isolated populations within pockets of human-dominated landscapes.
Okay.
And they struggle to disperse between populations, which then can lead to inbreeding and problems with...
So you can get genetic issues.
That's right.
Things that carry on that aren't desirable.
And that's true for so many species across the globe as the habitats get more and more fragmented.
Okay. So do you do a lot of work around making sure that there's pathways for them to traverse and things like that?
That's part of our work. The other parts are actually thinking about whether we actually need to kind of, subsidize the population somehow, bringing new individuals in possibly, but also just making people more aware of their local populations so that they can help to conserve them. And maybe, the best thing by far is to let the hedgehogs help themselves. So if you can create corridors, green corridors, and improve those for hedgehogs and other wildlife, that's by far the best thing to do.
Talk to me a little bit about how technology, especially like our PeakIO solution and like fast storage and this newer stuff that's kind of bleeding edge, how you guys are implementing it in today and where you might see it going in the near future.
I've had the privilege of working at ZSL for over 20 years now. And in that time, we've had a huge explosion in development of technology for monitoring wildlife and natural ecosystems. And that has had an incredible benefit to conservation, but it also represents some real challenges. So when I first got here, for example, we were using camera traps that we knew were really leading edge, cutting edge, new devices that we could use to monitor really remote and rare species like Sumatran tigers in southern Sumatra. But they were based on film cameras, so we could only take 36 rolls of images, 36 images in one setting.
A guy walks by, half of the camera's gone.
Or worse, you spend a day and a half putting out a camera in some really difficult remote area that you think is really important for your study. Come back a month later expecting to get all these interesting data on Sumatran tigers and find a troop of monkeys have become amused by the camera and taken 36 selfies on the first day. And, it's funny now, but it wasn't funny back then.
Right, I'm sure in situ that was probably a little more frustrating.
So the technology these days, here's a modern camera.
Okay.
Still, this is a camera that's not only cheaper than the cameras we used back then, but it could take thousands of photographs. It's actually a GSM link camera, so it can do real life transmission. Mostly we don't use these. We actually go a step down in technology where we use the digital cameras that store all the images on SD cards. But these cameras can then take tens of thousands of images, right? And because they're cheaper, you put out more, so you get a more complete picture of the landscape and where the animals are using the landscape. So you get more and more information. So with more and more information, more and more data, now loads of people are using, and we're working with other conservationists across the globe, developing kind of global networks of camera trap surveys, trying to combine data. So the Indian government does they do some of the biggest camera trap surveys. So everything is scaling up. As storage then is becoming increasingly a challenge.
Well, yeah, when you say camera trap survey, what kind of scale were we talking about? Because obviously it's not going to be just one in one SD card. That's easy to manage. Are we talking about hundreds, thousands?
Yeah, so I mean, even the London Hogwatch project has probably accumulated something like 15 million images since its start. The government of India is doing this on massive scales. They've got 10,000 cameras in one of their surveys. You know, their global, their India-wide surveys.
That's a lot of SD cards.
That's a lot of SD cards, a lot of bodies involved in this work, and a lot of pictures, right? So storage is an issue. And then a real challenge is processing the data as well. Genomics is another big area. We used to look at tiny, tiny fractions of the animal's genome to estimate population structures. Now we're looking at whole genomic structures. Really? And so that is a massive database as well. There's environmental DNA projects where they actually use DNA that's floating around the environment to use as a way of surveying environments and species there. All of this will involve more and more data storage.
All right, we're here in your lovely Edge data center. I see you've got a couple of DGX H100 systems, 8-way platforms. Those are the Nvidia reference too. Those are really nice looking. And then we've got the PeakIO solution just above that. That's got 1.2 petabytes of space per system, primary and a backup, feeding it with high-speed NICs. So that's kind of enabling all the fun stuff that you guys get to do in the software, right?
Yes, it's very exciting.
So this room is net new for the zoo as far as the technology is concerned, right?
Absolutely, yes, completely.
What was here before?
It was a reception room that nobody was using.
Oh, okay.
So it ended up being the home for Rhino, actually, which is what we've been calling it of late.
It is big and white, right?
It is, yes.
So I heard a little bit of a rumor about maybe some animals that weren't too happy about this.
Well, we had to, yes. So the chiller, which is outside, every time we had to do some work on positioning the chiller, and we had to replace the chiller at one point with a bigger unit. We needed to get the water deer moved inside because they got disturbed by the people, workmen doing the installation. So we had to kind of get their permission, the water deer's permission to kind of get the job done, really.
That's funny. It's a data center.
It was quite complicated. Just a complication you don't normally get in settings.
Most data centers aren't begrudging holding their construction plans to Chinese water deer, I would assume.
I know, but everybody was very understanding, so the
That's
water
good.
deer included.
But they're all happy now?
They're happy now. Yeah, they're fine.
Wonderful. Well, you guys have a ton of power packed in this guy, which is
exciting.
Very impressive and a wonderful thing to see at the edge, especially with the Peak solution. And those Solidigm 61 terabyte drives are really helping to drive the density and the speed for you. Let's go sit down and talk about how this impacts kind of your day-to-day. So we saw a lot of really cool hardware in the data center.
Yes.
What is that enabling you guys to do today that maybe you couldn't do yesterday, and where are you hoping it goes tomorrow?
Well, so I mentioned earlier that we have millions and millions of images that we need to process. One of the tools that we use that's really useful, especially for an urban camera trap survey, is something called the Mega Detector, which is a Microsoft product, which uses machine learning to pre-process the photographs. So what it does is it will remove humans and human-related objects like cars and sort them out. And then it does a bounding box around individual animals that it observes and that it can detect. And that pre-processing normally would take, for my normal laptop, it would go 3 images in a kind of minute or something. I mean, it's pretty slow, right? So this is really slow processing. On something like this, it does something like, I think, 30 images in a second. But then this is not being parallel processed, so you could presumably go hundreds of times faster than that, process whole massive data sets in a matter of a day or so. So the history of the Hogwatch project, I suspect, with its 15 million images, could be processed much, much more quickly.
And then where do those images, so after we go through the tagging, where does that feed into the cycle of maybe decision making or policy?
Well, that's only the first phase. That's the sort of pre-processing. The bounding boxes are then really helpful in terms of using AI for species recognition. And that's an area that's still very much an area of development for us. I mean, you would have thought we'd be better at it than we are, but there's still real technical challenges doing that. And you can tell the reason for that is that the images themselves the animals are often obscured, they're hard to see. There's a lot of sort of similar colored vegetation in the background. New approaches using just the bounding box area of the animal have really helped to raise the standards of species classification using AI. After that, then we'll pull together these data sets, and there's a whole range of different kind of analytics one can do. Some of the work we've been doing is using models that are traditionally used in physics, known as a series of models called gas models, to estimate animal abundance from this. And getting abundance data is incredibly important in managing wildlife populations. So if we can actually get a sense of how many animals are in a population in an area, that's a really important metric for conservation work. So ultimately, that's what we're going to do, but we'll also get great data on activity patterns of these species within communities. You get species richness, which give you an indication of the health of an ecosystem. There's just vast amounts of data and information you can get. And with AI, we're going to probably find new discoveries about how you can use this information.
What would you say is the biggest challenge that was solved, other than the speed of the tagging of the images? What was the biggest challenge that was solved when you were able to get this more high-performance computing and arrays?
Well, I think the biggest challenges now are, this mega detector tool that we've just described is really handy. It really saves us lots of time. The next big challenge is going to be species classification and getting that working really, really well. And I suppose the best way of doing that may be to continue to have sort of public engagement, public-assisted AI, human-assisted AI systems in place to kind of keep improving the AI tools. I think there are things that AI can do that we don't know what it can do yet. So there are challenges that we just are kind of at the cusp of understanding, really. I think things like looking at how species are interacting with each other in these big matrix of camera traps that we're setting up in the wild. And AI will be able to unearth patterns that we're not aware of. They'll drive new thinking in ecology and in conservation, I suspect. The ways of then scaling up to global scale studies. We're almost trying to think about, envisioning a time when we're sharing data globally, and almost like you have a weather system, a weather station, sort of understanding weather patterns, you might be able to look at global trends in species using global camera trap networks.
Well, this has been super cool. I really appreciate your time taking us through the data center and then kind of how this new technology is helping to drive some real world change and some positive stuff other than just, a ChatGPT prompt for I need a recipe for cupcakes. So, Chris, thank you so much for your time, and thanks for showing us around the zoo today, and thank you for having us. Appreciate it.
My pleasure. Yeah, no, it's great. It's great to be able to host you.
So to discuss the magic and everything behind the PeakIO high-speed storage system, all the infrastructure, how it's redundant, how it's fast, how it's big, we've got Mark from PeakIO with us. Mark, good to see you, my friend. And beautiful day we've had. Very unseasonably English day to be at the zoo and hanging out.
You brought it with you.
Yeah, we packed extra in the suitcase. So we saw something today that we really enjoyed, and that's an actual edge deployment of enterprise gear and some really high-end stuff, some DGX H100s, as well as the PeakIO solution. So can you dig in a little bit for me on what you put in there for them, what you put together, and why you did it?
Yeah, so starting from reverse order, I guess, as you know with Chris, one of the challenges is that they're innovating, and exactly what they're innovating they don't know just yet. But what they do know is that
they need better tools.
They need better tools to do that.
Yeah.
And the first hurdle which we talked about was that they've got, in one project alone, millions of photos. Now that sounds great, but you've got to put those millions of photos onto something for the DGX to do its magic.
Yeah.
And now you've got another million photos from another project, and they've got projects around the globe.
Yeah. And with data these days, it's the most valuable thing. You don't want to get rid of it ever.
No, you need to keep learning that data, and you don't know what you need until you've done it.
Yeah.
So you cycle and cycle. So although the concept is always easy, look, we just want to put photos on. You actually know after many of these developments and implementations that they need those photos to scale, and they need those projects to scale, and those DGXs are going to demand the performance.
Those are hungry GPUs.
Yeah, hungry GPUs, right? And you know, as you say, you've got to feed the beast. This is a bit of a cliche, but it's very true. So our job is to not just give them the scale, and to be fair, Solidigm, I've really helped with that by developing these amazing QLC drives.
Some of the most dense drives on the planet right now.
Absolutely. So there's a lot of work that goes into not just making them fast, but also making them effective within that Nvidia ecosystem of GPU direct. So you've got to scale it down, make it fast, keep it protected, and then you've got to back them up.
Yeah.
But as you know, these guys are innovating. Not Chris, for example, they don't want to be dealing with all the classic tools that we've had, dealing with information lifecycle management.
Well, they're zoological scientists.
This is what they're doing.
At the end of the day, they're not, sysadmins. They're not storage admins, which is,
exactly
a really complex discipline, especially today when we start bringing GPUs into it.
And there is, and to that point, what we're used to in the world of IT is people with 30 years of experience of sysadmin. In AI, there isn't anybody with 30 years of experience of working on DGXs because they're new. And what the problems they will have, we're only just finding out. So this instance in zoology was an amazing project because of what it demands. It pushes the boundaries, and we need so much power at such high performance in such a small space. That's one, but also what it's actually doing and what it's going to be doing, and that's really exciting to be a part of.
Yeah, it was super cool to see. Aside from obviously the power constraints, you guys, one thing I noticed, it was such a small footprint. It was 4 total U, and what was the total capacity? It was like 4?
It's 2.8 raw, so protected just over 2 or something like that.
Let's take a step back here for a second. So we've got the power of the DGX, which needs the Solidigm drives, which have the QLC and the density, and in aggregate they have the speed. What is the magic and the secret sauce that you're doing that ties those two together?
So we've got to aggregate them to give them that speed, which is at levels that we would traditionally associate with the HPC world. So we've got to get internally 200 gigs a second, which you would normally associate with many separate nodes. Then we've got to get it out to the world in an RDMA format that GPUs like, which is GPU direct. And so we put a tremendous amount of work, as have others, but in the industry in general, into like RDMA NFS, RDMA-based NVMe over Fabric, to try and pull these together to be able to deliver that performance that we've made to the GPUs. It's an entire ecosystem, and possibly the hardest aspect to this was simplifying that ecosystem.
So as part of the PeakIO ecosystem, in that architecture, it's handling the prioritization of the network traffic, the type of storage, right? Because I think it's block and object, and then we can do the backup, right? And that's almost near real time.
That's almost near real time.
Yeah.
And at the moment, in this specific, in ZFL specifically, the way we're backing up is morphing based on the way that they're using their projects. So we built those tools inside the PeakIO. And what we do in terms of the backup, we actually, for also security, we're using the NVMe over F to connect the 2 Peak boxes directly together via the switch, but virtually direct. RDMA, but with using block, it means that it can't be interfered with by anybody else. So we're adding a level of security, not just immutability, but that whole, the data's not moving between anybody else. Now, what we can do, which is quite unique to us as well, is should they need to recover, we can convert that NVMe over F pool into NFS, and the data's instantly there. So you don't actually recover, you just use it.
You just present the backup
The backup
itself
as a live working copy. So, and that's part of the ecosystem that we're developing. And like we said, there is nobody with 30 years of experience. So this isn't so much inventing, it's reacting to what's happening and what's becoming new and what's becoming evident and what customers need.
One of the things too that's really rewarding, at least about today for me, was being able to see, you know, these concepts that you and I have discussed for the last month or two, going back and forth as I learn about your tech, but also the tech that we've seen in our lab firsthand, and actually seen it deployed in a place where it's making, or at least helping to start to make significant changes in the world around us.
Yeah, and to be fair, I mean, clearly I'm not so as young as you, but do you know that's quite rewarding after, you know, a long career in IT, where most of our life, and there's nothing negative that this is about making things bigger, faster, better.
Right.
For us to be able to make something that is making a change, it's very rewarding to be a part.
Well, I think we learned a lot today, and had a good time for sure. I think I had fun with the penguins.
The penguins were awesome.
Yeah,
with the
jumping
laser
through.
especially.
Yeah, that was awesome. Well, thanks so much for your time, Mark. It was good to hang out with you here at the zoo.
Great to see you.
We'll see you
for your
around.
time.
Vince and I have had an absolutely wonderful time here at the London Zoo today. We'd like to thank our hosts of the ZSL and PeakIO for having us, especially a big shout out to Sophie and Chris for all their time taking us around and showing how they're implementing this enterprise technology and these GPU servers along with the PeakIO and Solidime storage solutions here at the edge. It's very exciting to see, and we can't wait to see where they go with this in the future with all of their learnings. For now, I'm going to head out to the jungle here and see if I can find any sloths.